7.3 is all about similar triangles, and 7.5 deals with similar parts of triangles. So if you remember, when we proved triangles were congruent, we had these 5 different theorems: SSS, SAS, ASA, AAS, and HL. Now, in order to prove triangles are similar, we have 3 theorems. The first is called AA similarity, which refers to angle-angle similarity. Next, we have side-side-side similarity. In other words, if 3 sides are proportional, then the triangles are congruent. The triangles are similar. And then side angle side. If 2 sides are proportional to the other 2 sides and the included angles are congruent, then the 2 triangles are similar. Seven 7.5 has theorems based on parts of similar triangles. The theorems are: if 2 triangles are similar, then the perimeters are proportional to the corresponding sides. Likewise, the altitudes are proportional, the medians are proportional, the angle bisectors are proportional, and the angle bisector divides the third side into proportional parts. This video is called Triangle Similarity Theorems. We have 3 similarity theorems to prove that triangles are similar. In the past, we had triangle congruence theorems, like SSS, SAS, ASA, and AAS. Now we have a statement called AA with that little symbol after it called a tilde, which means AA similarity. Another statement is SSS similarity, and the third statement we have is SAS similarity. So let's go piece by piece and explain what these mean. The first theorem we'll talk about is AA similarity. And that states if 2 angles of one triangle are congruent to 2 angles of another triangle, then we can prove that the 2 triangles are similar. Remember, the word similar means they have the same shape, the same angles, but the sides are proportional. So let's talk about an example of AA similarity. In these 2 triangles, let's pretend that we knew that these 2 angles are congruent, and also that these 2 angles are congruent. That's enough to prove that these 2 triangles are congruent. Sorry, not congruent, similar. The angles are congruent, the triangles are similar. So the statement that we would use to show that these 2 triangles are similar, well, let's give these triangles names. So if the 2 triangles that we have are called ABC and LMN, the statement we would use to show that they're similar is that triangle ABC is similar to triangle LMN. So that demonstrates AA similarity. The next similarity statement we want to examine is SSS similarity. And that states if the measures of corresponding sides of 2 triangles are proportional, then the sides are similar. Now that word proportional is extremely important. Proportions are essentially ratios that are set equal to each other. In other words, fractions of sides. Let's examine what it means for sides to be proportional. So if we knew something about the side lengths of this triangle, then we could maybe prove that they are similar using the SSS similarity statement. So let's put in a couple of examples. Let's pretend like these shortest side lengths are, let's say AC is 6 units long and LN is 8 units long. Let's also pretend that the medium side lengths are 9 and 12, and that the longest side lengths, let's say they are 12, and 15. Now, in order to determine whether the sides are proportional, we need to divide small triangle by big triangle and see if those fractions are all the same. So we'll set up our ratios by putting the small triangle ABC divided by the bigger triangle LMN. It doesn't matter exactly how you choose to set up your ratios, just make sure you keep them organized. So the shortest side length of triangle ABC is 6. The shortest side length of triangle LMN is 8. And we want to see whether that fraction is equal to the medium sides. So the medium side of triangle ABC is 9 units. The medium side of triangle LMN is 12. And we want to see again if the longest sides of the two triangles follow that same proportion. So the longest side of triangle ABC is 12. The longest side of triangle LMN is 15. So are these indeed equal fractions? If you take the red fraction 6 and 8 and you plug that into your calculator, 6 divided by 8 is 0.75. 9 divided by 12 is also 0.75. And 12 divided by 15? You guessed it, 0.75. And so that means all three pairs of sides are proportional because the fractions 6 divided by 8 is equal to 9 divided by 12 is equal to 12 divided by 15. So that's SSS similarity. By the way, I just realized I made a mistake. This side length shouldn't be 15. It should be 16. And that means that this fraction should be 12 divided by 16. Because then that does indeed equal 0.75. Oops, sorry about that. The last similarity theorem we have to deal with is SAS similarity. And that states if two of the sides are proportional to two corresponding sides, and the included angles are congruent, then the triangles are similar. Let's investigate that with a sample. So here we have two triangles, and let's again pretend that these angles are congruent, corresponding angles, and then let's also pretend that the side lengths, let's say that this short leg here is 4, this short leg here is 6, this short leg is, let's say, it's also 6, and this is equal to 9. So we know right off the bat that we have a pair of angles congruent. That refers to these angles. And so we want to check to see whether the sides are proportional or not, because we want to potentially use SAS similarity. So to verify that the sides are proportional, we'll need to check proportions. In other words, the shortest side of the small triangle is 4, the shortest side of the large triangle is 6, and does that equal the short side, the longer side of the small triangle divided by the longer side of the big triangle? Well, I know that 4 divided by 6, that simplifies to 2/3. And likewise 6/9, if you divide top and bottom by 3, that simplifies to 2/3 as well. So that means that the sides are indeed proportional, and so therefore these two triangles are indeed similar. This video is called Solving Problems with Similar Triangles, video number 1. In this video, our job is to find angle A, B, and C, and side length D, side length E. So let's take a look at angles first. We're given that the triangle MNP is similar to triangle QRS. And that word similar means, in terms of triangles at least, that angles are congruent and sides are proportional. So all of these angles are congruent. I see M is the first angle in MNP, Q is the first angle in QRS. And so that means that angle M is congruent to angle Q. So therefore, right off the bat, we know angle A is equal to 41. Continuing on with the angles, angle N must be congruent to angle R. And the reason that N and R must be congruent is N is the second letter of the triangle, and likewise R is the second letter of the triangle. However, we don't know anything about angle N and angle R. So let's take a look at the last angles named in the triangle. Angle P must be congruent to angle S. And since 82 is angle S, I know that B is equal to 82. And now, using the triangle sum theorem, let's just look at triangle MNP. We know 41 degrees is angle M. Angle P is 82 degrees. And that means C must be equal to 57 degrees. And the reason why is the triangle sum theorem. The angles in a triangle must add up to 180. So here we have A, B, and C. Now let's take a look at side lengths D and E. In order to find D, I need to figure out how the side length NP is related to the other triangle. So NP. I see in the name of the triangle that NP is the second and third letters of triangle MNP. So second and third corresponds with second and third. And so now we have one ratio. In order to solve with a proportion, we need another ratio. And in particular, we need a known ratio. By known ratio, I mean we need to know something about both pairs of sides in the triangles. So MP is a known side length, and MP corresponds with QS. And QS is also a known side length. And so we can set up a proportion using that known ratio, MP and QS, and we can set it equal to the ratio that we're looking for. Now let's substitute in those values that we know. NP again refers to this length. NP is unknown, that's D units, divided by RS, which is 12, and that equals MP over QS. And so now we can solve for D by cross-multiplying. D times 24 is equal to 12 times 56, which is 648. Divide by 24 on both sides, and we get that D is equal to 27. So now we found D. Now the next job is to find E. So length E refers to the side length QR. So let's set up our ratios as QRS, triangle QRS, divided by triangle MNP. So length QR correlates with MN. So QR divided by MN is one ratio. And in particular, it's one of the unknown ratios because length E is unknown. So that's the unknown ratio. And again, it's unknown because QR is unknown. And we want to set that ratio equal to a known ratio. The only known ratio in this pair of triangles is 56 and 24. In other words, it's length QS, so first and third, and then the corresponding side to QS, first and third, is MP. So now we have two ratios set equal to each other. We have our proportion, and our job is to solve that proportion. So QR again is unknown, it's E units. MN is known, that's 42. And that's equal to QS, which is 24, over MP, which is 56. So let's cross multiply. And then if we divide by 56 on both sides, we get that E equals 18. With this problem, it's tough to know where to start. I've got a whole lot of variables. I've got Y, I've got X, I've got N, I got R, I got T. So many variables, it's hard to know where to start. What I would recommend is take a look at this triangle, triangle ABC. In that triangle, we have two angles where Y is the variable. And so that kind of gives you a little clue that Y is sort of the starting point for this triangle, this similarity problem. So let's take a look at these angles, A, B, and C. The triangle sum theorem says that all three of those angles have to add up to 180. So we know angle A, B, and C add up to 180. So therefore we get this new equation. So let's combine like terms. If we subtract 45 from both sides, and then divide both sides by 9, we get that Y is equal to 15. And so that piece of information is kind of a linchpin, sort of a key to finding out a lot of other side lengths. Sorry, not side lengths, angles. I know the measure of angle A is 74. Because y is 15, you can substitute that value in for 5y minus 1. We can do the same thing for angle B. We know B is equal to 68 degrees. Because if we substitute in 15, we get 68. And now we can use that information to help us find some other angles. For example, let's take a look at angle D. Angle D must be equal to angle A. And the reason why is, since these two triangles are similar, A corresponds with D. And so that makes their angles equal. And so 3t plus 11 must equal 74. When you solve that, you get that t is equal to 21. Now we can do the same thing for r. I see r is related to angle F. Now F corresponds with angle C. Since those angles correspond, they must be equal. And so now we can say 2r plus 4 equals 38. When you solve that, you get that r is equal to 17. So now the only thing that's left are these side lengths. In particular, we're missing side length x, 3x plus 2, and n in 2n plus 2. So I'm going to clear the page and let's take a look at side lengths. So let's ignore the angle information for now. I need to find what x and what n equal. In order to do that, I have to use a known ratio. So let's first solve for x. The side 3x plus 2 refers to AC. So let's use AC as a ratio. I know that AC is the first and third letter of triangle ABC. So therefore AC corresponds with DF. That's our unknown ratio. And we want to set that ratio equal to a known ratio so we can use proportions. The only known ratio here is AB, which is first and second, and DE. So in order to set up my proper ratio, I'll have to set up AB on top divided by DE down below. So now we need to cross multiply. 12 times the quantity 3x plus 2 is equal to 15 times 16, which is 240. The first thing to do to solve that will be to distribute 12, then subtract 24 from both sides, and then divide by 36 on both sides, and we get that x is equal to 6. So now we found x. The last thing that we need to find is n. Since the only thing that we need to find is n, I'm going to cover up a bunch of this stuff. We already know what y is. We already know what x is. We already know r and t. And so the only thing left is to find n. And n refers to the length FE. The corresponding side length of FE, if you look at the last two letters of triangle DEF, corresponds with the last two letters of triangle ABC. So there's our unknown ratio. In order to solve that, we'll need to set that ratio equal to a known ratio. The only known ratio we have, remember, was 15 and 12. So DE and AB. Now, since I have FE on the top of this ratio, and FE is the second triangle, I need to put the second triangle on top in the next ratio. So DE corresponds with AB. Cross multiply. Let's distribute the 15. And now we're done. This video is talking about solving problems using similar triangles. And in particular, we're going to use similar triangles to solve this word problem. So Carl is measuring the height of a pine tree that he was standing next to by comparing it to his height using the length of his shadow and the tree's shadow. Carl is 6 foot 2 inches tall, and his shadow is 2 feet 6 inches tall. The tree has a shadow of 32 feet long, and we want to find the height of the pine tree. So it helps to draw a little picture. So here's a pretty cruddy picture. Here we have Carl, and here we have a tree, and then there's shadows that are sort of laid upon the ground. So we know that Carl is 6'2", and his shadow is 2 foot 6 inches long. So 6 feet is the same as 72 inches, because there are 12 inches in a foot. So therefore 6'2" is 74 inches. So Carl is 74 inches tall. His shadow is 2 feet 6 inches long, which is 2 times 12 plus 6. The length of the shadow on the ground is 32 feet, but the height of the tree is unknown. So let's call that x. So we'll set up our proportions, Carl divided by tree. And now Carl's height is known, but the tree's height is unknown. We'll use the ratio of shadows as the known ratio. Carl's shadow is 30 inches long. The shadow of the tree is 32 feet long. And so since these two triangles are similar, we now have a proportion that we can solve using cross multiplication. We have 30 times x is equal to 72 times 32. And so our final answer is 76.8 feet. And that's how tall the tree is. By the way, I made a mistake in this video. 72 isn't correct. Go talk to your teacher. Maybe they'll give you some extra credit for finding that and fixing that mistake. So here are a couple more problems dealing with similar triangles. We want to find the height of this building given the fact that we are looking across a flagpole. So we're still dealing with similar triangles. And let's trace out those triangles. We have a triangle here, and then a larger triangle that includes the height of the building. So in order to find the height of the building, x, we want to figure out how to set up proportions. So the height of the building is unknown. That's x. The height of the flagpole is known. That's 6.5 feet. So let's set that ratio equal to ratios in length. The length from this viewing spot, right here, to the base of the flagpole is 42 plus 7 feet. In other words, it's 49 feet. That corresponding distance in terms of the flagpole is 7 feet. So now we have our ratios. Let's cross multiply to solve the problem. 7 times x and 6.5 times 49. Dividing by 7 on both sides gives us that x is equal to 45.5 feet. Let's take a look at one more problem. Here our job is to find the length of this lake. It's kind of a cruddy looking lake, but let's pretend that our job is to find the length of AB. So this fact, the fact that AB is parallel to DE, that tells us some information about the naming of the triangles. So if AB is parallel to DE, then we know that, for example, angle B would be congruent to angle D, because they would be alternate interior angles. If you also consider the vertical angles, created by point C, I know that these two triangles are similar by AA. And in particular, let's name the triangles. So triangle ABC would be similar to triangle EDC. And that information will help us set up proportions to find the length of the lake. Let's call that length x. So I know that the length AB corresponds with the first two letters of the second triangle, ED. There's our unknown ratio. And now we're looking for a known ratio. I see 20 refers to length BC, and that would correspond with length DC, so 50. So for the known ratio, we'll use the length BC, which corresponds with DC. So let's substitute the values of those lengths. AB is unknown, let's call it x. ED is known, it's 40 meters. And that equals BC, which is 200 meters, divided by 50 meters. And so now we'll solve for x using cross multiplication. So the lake is 160 meters across.